57 or so minutes, we will try to cover a quick intro to artificial intelligence and machine learning delivered by yours truly, followed by a hands-on demonstration of an AI-enhanced virtual patient by Nick Stoic, our VP of Sales. And finally, we would be happy to answer any questions you may have for us about virtual patients, AI, or pretty much anything else. So let's get started with theory and our intro to AI. In this segment, I'm going to talk about what is artificial intelligence, also known as AI, why it is important to us simulation professionals, and we will also get a quick primer on the current techniques of AI development. Finally, we're going to assess how the AI of today is relevant to patient simulation in 2020. So what is artificial intelligence? Well, the definition of AI is pretty dynamic and it really does change over time. One way to look at it would be to say that AI is any technology with sufficiently human-like capabilities to feel like magic at the time. So it is technology that either has been developed recently or one that we expect to develop in the near future. Because of that, over time, what we perceived as AI may no longer be perceived as AI as today. So some examples, 30 years ago, computers playing chess was definitely artificial intelligence. Today, not so much. 20 years ago, automatic document summarization was AI. Today, every newsroom and even some legal offices use such tools. 10 years ago, computers recognizing images at human levels was state-of-the-art AI. Today, we can all search our photos by the person in the picture, which is using the same tools and techniques as these image recognition AIs. So we really should expect that the perceived definition of what qualifies as AI is going to continue to shift in the future. AI really is a spectrum of capabilities, ranging from narrow AI with a single capability to strong AI or artificial superintelligence. All AI today is weak or narrow AI, and nobody knows when or even if we will ever see strong AI. Having said that, we have yet to see any reason to believe that strong AI is impossible to create either. The technologies behind AI really changed over the decades of AI development. Yesterday's solutions are just insufficient for today's AI problems. So let's take a look at how these approaches evolved. Most importantly, AI is not a new thing. The basic concepts were developed at the very beginning of the computer age in the late 1950s. Most experts at the time believed that we are just a decade or two away from building strong AIs, which is interestingly exactly what many experts believe today. We are just a decade or two away from building strong AIs. So that's interesting. However, this is no reason to question the progress that has been made in the last 60 years. We just don't know exactly how much closer we are to strong AI today. The first 30 years of AI research focused on symbolic AI, which is based on high-level symbolic, human-readable representations of problems that the AI is trying to tackle. After some initial success in various fields with chatbots, chess, and natural language processing, progress halted, and the field experienced the first AI winter. This really was a period of disillusionment when AI was no longer seen as the next big thing, but rather a dead end with no breakthrough in sight. But something changed, something in the 90s, most importantly, the increasing data processing and storage capabilities of computers paved the way to an entirely different approach to AI called machine learning, or ML. So what is machine learning? At the gist of it, machine learning is about setting up computers to learn something on their own without providing explicit instructions. We, the human programmers, establish some models and provide data, and the computer gets to work to adjust the model until it solves the problem as represented in the data. Today, almost all machine learning systems use some form of neural networks. What are these and how do they work? Well, although they were indeed inspired by nature, they do not really resemble or even try to simulate biological neural networks. Rather, these are very abstract mathematical representations of limited small-scale networks of neurons. So let's see that in a little more detail. So here is a graph representing a neural network. Every single gray dot here is a single neuron. A neuron in this model is a simple number cruncher. It has some inputs, so we can feed numbers into it. And based on its inputs, it generates, calculates outputs, which are numbers again. Each of the gray dots here represent a single neuron, and each of the lines are various inputs and outputs of those neurons. This is how these neurons are connected. So the output of one becomes the input of others. This is how they form networks. All these neurons can be described by how they tweak their inputs to generate their outputs. The connections of the network and the output functions of individual neurons all together define the characteristics of this neural network, i.e., what input is going to trigger what output at the network level. So how do we get neural networks that are actually useful? Useful in the sense that on their outputs, they can indicate some insight about their inputs. Surprisingly, the process to getting such networks is pretty much by chance and with some evolutionary tweaking. So it's really a three-step process. First, we grab a bunch of neurons, virtual neurons, and connect them completely accidentally, just by chance, as randomly. Then we start feeding the inputs of our data set and check the output. Finally, we start making minor adjustments to the neurons, their output functions, and their connections, and try again, and again, and again, many, many thousands of times. So you can think of this process as a rather inefficient form of bot manufacturing, one that gets us to the perfect single bot for the task at hand by building thousands of different bots by trial and error, looking at every one of them, finding the best, and throwing away the rest. In this metaphor, a bot has some kind of a skill and represents a certain neural network. Our factory of bots, really just a piece of software, needs to build a lot of bots, neural networks, train them all, sets neurons, parameters, and connections, and test them all to find the very best ones. Once the best one is good enough, we throw away the rest of the bots, and our bot manufacturing is successfully complete. So let's see an example of a really useful bot. So, because it's really theoretical sounding, our example is going to go around image recognition. So first, before we get into that, quick disclaimer, we're going to oversimplify many things in this example as we have to complete our overview in a matter of minutes, not days. But we are still going to cover enough detail to gain some really interesting insights. So imagine that we are set out to build the most useful neural network of them all, one that identifies kitten pictures on the internet. After all, isn't sending around kitty pictures the #1 reason for the development and the existence of the internet? So first of all, for that to be able to happen, we have to find a way to feed all our beautiful kitten pictures into our neural network, which can only take numbers as its input. So how do we do that? Well, that's relatively easy. Computers are pretty good at representing visual information as numbers. So the way we do it is that we just break them up, all the pictures, into pixels, small pixel elements, and take the numbers that represent the intensity of color of each pixel. This is what's visible in this slide that you can see right now. Our picture can be now transformed into a nice series of numbers, which now we can use as inputs for our neural network. So our pictures are ready to be fed into a neural network. What do we do next? We build a neural network that takes those numerical representations of an image, the color values of all pixels, as its input. And this neural network will only have two outputs, which we're going to name "this is a cat" and "this is not a cat." Neural networks really tend to work best when we do not try to ask them to make black or white decisions, but rather they give us probabilities of their predictions, i.e., how sure they are in their insights. This allows for more flexibility and enables using mistakes as learning opportunities, and also avoids overtraining to our initial sample data set. So this is why we have these two outputs, each of them able to show us smaller or bigger numbers. When we feed our network with a cat picture, we would like to tweak our neural network to get to the shape and form that when it sees a cat picture, it is going to give us a rather big number on the output, "this is a cat," so indicating that this is pretty sure that we are feeding it a cat picture, and a really low number on the output, "this is not a cat," as that will indicate with a high certainty that we are seeing something else, and that's not a cat. So that's simple enough, right? Problem is that our neural network, as we get started, has absolutely no idea how cats look like. So when we start with a random bunch of neurons, it is going to give us pretty much random numbers on its output. Sometimes it will recognize a cat, sometimes it will not, but mostly it will just give us absolutely random numbers, no matter what we feed into it. That's definitely not good enough. So we need to start generating and then trying an enormous number of neural networks, these little bots busy at work, and pick the ones that seem to be somewhat better than random at picking cats. How do we check that? Well, we feed them all with as many cat pictures and non-cat pictures as possible, and keep an eye on their outputs for all those pictures. This is the first important insight. The more cat pictures we show them, the more likely we will find bots that will not only be able to recognize cat pictures on those images, but also will be later able to deal with pictures of kitties they have never seen before. As they learn to perform well with a larger training data set, they are becoming better at some form of generalization. This is why the amount of training data is key to the performance of machine learning. The networks that seem to be better at the job are then adjusted and tweaked and tested again with the same huge data set, always testing their performance in identifying cats as well as not cats, because we need to avoid false positives too. Otherwise, the network would just say it's a cat for every incoming picture. If we only train them with cat picture, that's not good enough. So we continue to alter our network until we reach a satisfactory level of performance. So what do we get as the end result? A network of number crunching neurons that does a shockingly good job of identifying cats, even in pictures it has never faced before. Yet, it has no idea what a cat is or how a cat looks like, for example, that it has eyes and ears. Surprisingly, neither our neural network, nor the computer programmers, nor the test process have any idea how our network works. We just found that this particular network does this job pretty well through experimentation. These machine learning neural networks are in some ways much more simplistic, and in others more capable than biological neural networks. So the parallel breaks down on many, many levels. Yet It is really difficult to resist the temptation to see the millions of rapid adjust, test, repeat training cycles as some form of accelerated evolutionary selection and training process. The capabilities of computers running on neural network, that's what limits its scale and probably its abilities. Too much complexity, too big of a neural network would result in highly impractical training times and would require computers that are so big that they don't exist today. Although the number of neurons in a virtual neural network is not a good way to evaluate the capabilities of it, and we have really no idea whether a simplistic number crunching approach simulates all what matters about the biological neurons, it is still interesting to see how our artificial neural networks compare to live ones in scale. Today's state-of-the-art AI systems use neural networks, often multiple ones in a system for various functions, made up of several hundreds to a few thousand neurons. So this is roughly the scale of the nervous system of a jellyfish, 5,300 neurons, and is dwarfed by the brain of a lobster, 100,000 neurons, not to mention a rat, 100 million neurons, or a human, 100 billion neurons. So as you can see, the current AI, artificial intelligence neural networks are tiny by comparison of actual biological neural networks. So as of today, we're essentially teaching a jellyfish to drive a car, to transcribe audio, or to recognize pictures of cats, instead of doing all the things jellyfish scale nervous systems normally do. So this is surely challenging for the jellyfish-like network. Amazing that it sometimes works. And no wonder we have no clue how it is doing it. Machine learning algorithms embodied in bots are everywhere and are transforming our expectations and our relation to technology in a wide range of applications. Such bots trade our stocks, pick our next video, attempt to alter our political opinions on social media, recognize us, and unlock our phones. Machine learning is here to stay with some amazing capabilities, powered by internals that nobody truly, fully, deeply understands. Machine learning-based solutions are becoming ubiquitous in all fields of healthcare. We see startups, established companies, and research institutions offering AI-enhanced tools for various aspects of health science research, patient and doctor assistance, telehealth applications. Machine learning is being seen as an enabler for technology to break into fields that were previously just a bit too complex, too fuzzy, and too confusing for computer software to conquer. This is why we see the greatest potential for machine learning in fields like medical imaging analysis, medical record data mining, and genome research. It seems like that the major established healthcare simulation companies are somewhat slow to embrace AI technologies, and there is only one company that developed markets AI-driven simulation products. We expect that is going to change in the near future, and those who today might still insist that AI is just an empty buzzword or an unnecessary gimmick for patient simulation are going to give in and eventually embrace these new capabilities. So why AI in healthcare simulation? AI matters for healthcare simulation because it enables something important and definitely transformational: a new modality of simulation. As this only happens once every decade or two, I'm sure you think that this is a pretty boastful claim. Well, let's see. Every time a new modality of patient simulation was conceived and adopted, it enabled you, the simulationists, to deliver those low-risk simulated learning experiences across a new combination of simulated dimensions of the real patient encounters. AI virtual patients uniquely combine some of the communication simulation skills of standardized patients and some of the physiological simulation abilities of patient simulators. So let me emphasize that traditional procedural point-and-click virtual patient experiences placed in virtual reality or even augmented reality are not really creating a fourth modality of simulation. Rather, they are making very important advancements to improve the realism of screen-based simulations. But we're talking about something else here. Radically new AI-driven capabilities, such as natural communication skills, AI-based skills assessment, and visual input analysis, these can enable our virtual patients to simulate listening, talking, seeing, and feeling. Finally, before we move on to the practice part, let's take a quick look at how a patient communication simulator can listen and talk using advanced machine learning. Whenever a PCS, a patient communication simulator, is asked a verbal question, these 5 components you see listed on this slide jump into action and all work in sync to give a scenario-appropriate verbal answer. Each and every one of these components use neural networks that are constantly trained to improve their performances. For example, when we have to differentiate human speech from other noises, so we know we have to start listening and eventually answering, we use a neural network to detect human voice activity. On a next one, Google's most advanced speech recognition services utilize neural networks that are trained by billions of smartphone users every day. The PCS grammatical analyzer and input classifier, some might say are secret sauce in this process, are also driven by neural networks trained on a rapidly growing data set of clinical interview questions expanded with every PCS simulation session. Finally, when it comes to verbalizing that response, neural network-based models have been the key to some less machine-sounding voice synthesis. So more lifelike voices for our virtual patients. I hope you found this quick intro to AI technologies interesting. There is so much confusion and uncertainty in the media around AI and its impact on the future of our society. For a really good reason. Machine learning driven technologies and new capabilities of computers are indeed nothing short of magical. But they have not changed the quintessential nature and purpose of computers. They are tools to assist us. As Steve Jobs famously said, a computer is a bicycle for the human brain. To get the most out of these amazing new tools and technologies, we all have to learn how to ride the bike. In the case of AI virtual patients, this means learning how to get the most out of our smart virtual patients, which brings us to the practice part of our workshop. And with that, I hand over to Nick.
Thank you, Balazs. Hello, everyone. Let me just see here. I want to share my screen. All right, so you guys should be seeing my screen now. So as just a quick introduction, again, my name is Nick Stoic. I am the VP of Sales for PCS. And today I'm going to be going over the PCS Spark platform for digital patients, which incorporates a lot of the AI and machine learning technologies that Balazs just went over here. So we're going to kind of pretend that I am a med school student and I have just logged into PCS Spark. And what I'm going to see here is basically the list of simulators or the list of classes that have been assigned to me. So I have down here, you know, Med School 101. I'm a fresh med school student. And all I have to do is click on this start button here, and I'm going to see the list of patients that have been assigned to me. So today I am going to work with Valerie Miller. Valerie Miller is kind of our clinical skills essentials case. So Mrs. Valerie Miller, she's a 34-year-old female, and she has come into the clinic today with complaints of a headache. All right. So I just need to click on this start button here, and then immediately I am dropped into the simulation. The first thing that I see as a student is going to be the lifeline. And the lifeline is here to serve a couple of different purposes. The first one of which is just, a quick tutorial on using the software. If I had never used it before, there's some instructions like making sure to allow a microphone, but there's also some tips on speaking with an AI, reminding students you don't need to talk in a robot voice, just speak naturally, and those kinds of things to remember when just speaking with an AI. And then the further down I scroll, you'll also see that we have basically interview objectives of the case that we're working with here. So asking, what kind of questions I should be asking, and that sort of thing. So you can see here we have the old car's mnemonic, for example. Once I've, pretty much digested all of this information, I'm ready to pretty much begin speaking with my patient. And all I need to do that is click on this video button here. And immediately I am, sat in front of Valerie Miller. So this is one of about 7 or 8 different patient avatars that we have. And she is currently in our clinic environment. So to begin speaking with her, all I need to do is click on this microphone button here. I'll introduce myself, and we'll go ahead and get this interview started. Hello.
Hello. How are you?
I'm doing well. My name is Nick. I'll be taking care of you today.
Great, thank you.
What's your name?
My name is Valerie Miller.
And I just want to take a pause there and kind of remind you guys everything that's happening during these interactions. So every time that I'm speaking with Valerie here, my voice is essentially being sent to Google, which then transcripts my voice to a text file. And then that text file is fed into the PCS communication engine. That's where all the AI components happen. And then it matches up my question or my statement with the correct response for the patient that I'm working with, and then outputs that in another text file, which is then sent to Amazon to do the speech synthesis, which then plays back the audio file that we hear there. All of which you're seeing is happening in a little under, a second, if that. But I'm going to go ahead and keep speaking with Valerie here, kind of find out what she's come in today and what kind of symptoms she's experiencing. So what brings you in today?
I've been having these horrible headaches for the last few weeks.
Okay. And when did they first start?
It's been 2 weeks now.
Okay. And where are the headaches located?
It's usually on the right side of my head.
Can you tell me what they feel like?
Would you please clarify?
What do the headaches feel like?
They feel sharp and at the same time, they're pounding.
And is there anything that makes them worse?
Nothing makes it worse. I just have to get through it.
Okay. Is there anything that makes the headaches better?
Time. Rest. I'll try to find a quiet, dark room and lie down until the headache goes away.
How long do the headaches usually last for?
Every headache lasts anywhere from 1 to 2 hours.
Have you noticed any other symptoms?
Sometimes the headache will get so bad, I'll feel really nauseous.
So you can see here, we can keep going into the chief complaint and the issues surrounding that chief complaint. But Valerie's also really a fully built out character in the sense that we can ask her about her past medical history. We can ask her about, her social history, her family, all of that. So I'll show you some examples of what that looks like as well. Have you ever had any major surgeries in the past?
I had an appendectomy when I was 15.
Is there any other medical conditions that you have that I should know about?
No, I don't think so.
And what do you do for work?
I am a property tax assistant at Ducharme, Macmillan and Associates.
What do you like to do for fun?
I do a lot with the kids. And I like to read and cook.
Are you married?
Yes, I am married.
What's your husband's name?
His name is Peter.
Do you drink?
I'm not a big drinker. I drink a glass or two of wine occasionally.
Do you smoke?
Yes, I smoke.
How much?
I smoke about a pack per day.
Now, I just want to point out one thing here, which is pretty neat, and it's about one of the more recent updates that we've made to the PCS communication engine, and it goes back to context and being able to contextually understand what's going on. So previously, we didn't really have much of an idea of what was said before a question was asked. Every question was kind of handled independently. But now we're actually able to take into consideration context about what was being asked previously and then, follow up with the correct answer. So when I asked her how much, she knew that I was speaking about smoking. So she relayed the information of, I smoke, X packs per day. But there's, so many how muches I could have asked, like, how much medication are you taking? Or, how much do you drink? So while it seems small, it's actually a pretty big technical challenge for us to be able to make it as natural as it is. So that's kind of an overview of what the verbal interaction looks like with our patients. Once that's done, though, we also have the ability to perform a full physical exam. And that is initiated, one of two different ways. The first of which could be, supernatural. You're still speaking with your patient and you say, Valerie, I'd like to take a look at your eyes now. And then what will happen is she'll take a step back, her clothes will come off, and then we can do the full physical exam. The other way is we also have this little button down here. We can click on that and that will initiate the physical exam as well. So I'm going to go ahead and do that. And then, like I said, she'll take a step back, she'll take her shirt off, and then we have access to a few different icons now. So we have this eyeball icon here, and that's kind of a visual examination. So if I click on that, then I have the ability to actually mouse over different organs. So let's see here. If I mouse over the eye, I'm able to take a look at the eye. If I mouse over the ear, I'm able to take a look at the ear. So we'll see what that looks like if we wanted to take a look closer at the eye, see if we can see anything neurological going on. And when I do that, I get both a kind of a text interpretation of what the finding is, but then I also get a visual indication of what the eyeball looks like. And for here, the eye looks good, so there's really no concerns there. I can move on in my physical exam. So if I wanted to look in the ear as well, let's see, I can click on the ear. Same kind of deal here. I can, see the text findings, but then I also can look at the inside of the ear and make my own interpretation as well. So you can also do that for, the nose, the mouth, and so on. The other icon is this little ear, and that's for, listening for sound. So that's more auscultation. So if it was relevant for me to listen to the heart, the lung, the bowel, all of those sounds I can actually listen to and then get audio feedback on what we're listening to. So let me show you that. And we have a little stethoscope icon that pops up when I mouse over her chest. And I'm going to turn my volume up here so let's see if you guys can hear the heart sounds. But we also get a little log message saying I'm listening to the heart sound at the pulmonic area. So if that was pathology, we could also hear that pathology while listening to the heart sounds. And then finally, we have this little hand icon here, and this is for more, physical palpation. If there was something going on with the abdomen, I could palpate on the abdomen, see if there's any findings there. I can also check her heart rate, just by mousing over her, radial or carotid pulses. So that is what the physical exam looks like. So once the physical exam has wrapped up, the final thing that we have or allow for students to do is actually go in and order lab work or medical imaging to kind of further confirm what they think their diagnosis is. And to do that, all I need to do is click on this orders button down here at the bottom, and then I'm automatically taken to the orders section of the simulation. So here I'll see a list of the available orders that I can select. So we can see here, I can order a CT image of the brain, I can order an MRI of the brain, I can order an ultrasound, an X-ray, lab work, all of that. So I think for this case, since we're looking at a headache case, I'm going to start with a CT scan of the brain, and maybe we'll do some blood work as well. So I'll check that lab, and then all I need to do is click on order selected, and then immediately it pops up here. I have my available order, the orders that I've ordered. So we get a text interpretation from the radiologist, and then we also get an image of what the CT scan looks like, and we find out that the brain CT does show some kind of swelling, so we'll have to take that into consideration of our diagnosis. And then we also, if we wanted to look at the blood work, we can click on that as well and look at those results and see if there's anything relevant that we need to pull from. So at this point, I've kind of, done everything I can to help formulate, my diagnosis. So, one option that students have is we could come back here to the video section and scroll down a bit, and we'll see our log here. So you can also, have your students type in, diagnosis, and then what we think the diagnosis is, and then choose to add that to the log. And also, I do want to point out here in the log section, everything is captured. So every interaction that the student or the learner has with their virtual patient, it is being captured and transcribed. You can see it here with this little stethoscope icon, and then everything that that the avatar responds with is indicated with this little person icon here. And then if we scroll down even further, we'll be able to see all the times that I performed a physical exam action, or all the times that I ordered blood work. And then finally here at the bottom, we'll see where I put my diagnosis at the end. So all that information will be available to faculty to review. But the cool thing is that when I finish my simulation, all I need to do is click this stop button up here. I'm able to get automatic assessment on how I performed. So you can see here I got just a 53% out of 100%, but I have all of these different categories here in terms of how I did with the chief complaint, how much of the history of present illness I was able to obtain, past medical history, family history, and social history. So all of that is automatically scored and provided to the student when they are done with their simulation session. And then if I go back in the log as well, I can actually see as a student, what I received credit for during my simulation. So that is what the simulation experience looks like from a student's perspective. And what I want to do now is actually take a back here and show you guys, while we do have basically, 9 bundled patient cases that come with PCS Spark, really the power in this tool is the ability for you guys to go in and create your own custom patient cases that really fit in and match with your curriculum. So what I'm going to do is actually log out of my student account here, and I will log into what is more like a faculty account, and we'll show you how easy it is to go in and build these own virtual patients and edit their responses, and then actually see how they operate. So if I go to my patients tab here, I have a list of my custom patients, and I already created just this copy of Valerie Miller. I named it Valerie Miller SSH. So that's the one that we're going to work with. And we will go ahead and open that up. Now, let's say we have a headache case here, but we want to create an abdominal vein case as well. So all we need to do for that is type in, abdominal pain. So that just kind of indicates what the case is from our perspective. And then we will do the majority of our work in the states tab. So I'm sure if you guys have worked with patient simulators in the past, you're probably familiar with the idea of different states. So we have support for states here, support for smart switching of states, and so on. But all we'll need for this is the initial patient state. So if we go ahead and open that up, first thing we'll see is, the vitals page. Don't really need to change anything here, but we could if we wanted to. On the sounds page, since we do want to make this an abdominal pain case, let's just go over to the bowel sounds and we'll set it as ulcerative colitis. So now when a student, listens to the bowel, they will, they'll hear something different than just a normal bowel sound. And then where all the heavy lifting is kind of done is over here on the conversation tab. So we already have built out all of these different categories and topic and responses. So a lot of the work for you guys when going in and creating these custom patient cases is already done. All that needs to be done on your end is just changing the response. So for example, with the present illness, let's click on that category here. And we have the topic and response, chief complaint. So right now it's set to be, I've been having these horrible headaches for the last few weeks. We already saw that when we were speaking with Valerie Miller. If I wanted to change this, all I need to do is type in here, I've been having bad bloating, let's just say. And then I've been having bad bloating, we hit return, and then now that response is locked in. So what we can do is click OK. We have that saved. And then now all we need to do is assign this patient case to our students to actually be able to go through and run. So to do that, we'll go back over to our simulators list. We have our Med School 101 simulator here. So if I click on this cog wheel here, I'll do just a quick adding of that patient case. So we'll scroll down to Valerie Miller SSH, abdominal pain. That's available now. And then if I log out here, log back into my student account, and I should see Valerie Miller SSH now as an assigned patient. So if I click start here, we have the same lifeline available. We have Valerie Miller. She'll show up here in just a second. And let's go ahead and ask her, what brings her in today? What brings you in today?
I've been having bad bloating.
So you can see there. Now, of course, it's a little bit more time consuming when you're going in and creating these custom patient cases, because you do need to, really update all of the responses to match the patient case that you want to create. But you can see there how quick and simple it is to kind of get started. And one of the other two things I wanted to mention were that when you do go in and create these custom patient cases, you can choose from a range of different avatars, from, a 12-year-old girl all the way up to, a 70-year-old man, ranging in different ethnicities, as well as choosing what kind of environment you want it to take place in, whether that's the clinic, whether that's the hospital, the ambulance, or a home health environment. And with that, I think that is pretty much everything I had planned today. So we've got about 10 minutes to open it up for questions. I think you guys can either enter in questions in the chat, or I think that's probably going to be easiest, actually. Okay, and I'm just, oh, I'm sorry, what was that?
Hi, Nick, this is Yuming Huang. I just chatted some of my questions.
Yes, no, I see those. So I'm just reading. I'll just kind of run through.
Answer those because I'm already started typing in, so let me answer those.
Okay.
So number one, the heart rate is really an audio feedback, so they can hear it, and if they use a any kind of watch or anything else to measure the time for that, they can use that. Blood pressure measurement, as of today, that's mostly on the digital virtual patient monitor. But we're planning on adding a sphygmomanometer-based assessment to that because we have the infrastructure for that as well. Accents, the nice thing about using, essentially standing on shoulders of giants, is that we're doing as well as accents as the best of the industry, namely Google in this case. If Google Assistant understands an accent, Spark is going to understand it just as well. So that's really, really good in flexibility. Additionally, we have the ability to fine-tune the expected accent in terms of British English, Indian English, or Australian English. And we can set that to a specific patient or to a specific simulator, answering Natasha Taylor's questions as well here. Finally, for the authoring tool, can we upload our own imaging studies and auscultation sounds? Yes, on the imaging, not today for the auscultation, at least not as in a self-service way. Having said that, our customer support team would be glad to work with you on incorporating your own auscultation sounds in patients. It just takes a couple of days. It's not immediately available, but as part of the patient authoring assistance services that we provide, we would be more than happy to integrate your own auscultation sounds in there.
Same for sort of like video clips, like TTE. And
video clips and images, that's completely self-service. You can do it at the minute you put in the picture or the URL of the video, and it will become available as part of the order that your students can get. We didn't have much time to talk about that, but it's what's really nice about the orders capability, that you can customize the results of all those orders, including certain physical exam items, to your particular patient. So if you create a patient where the eye exam should show something abnormal, you can just change that picture or even change that to a video clip showing that abnormality on your own with the power of the authoring tool set.
Great. I'm not sure if I missed it, but did you say there was a text feature in case like somehow the mic doesn't work or something happens where they don't recognize your speech?
Yes, we have the ability to ask questions through typing, but I have to tell you that using a verbal interaction is extremely powerful in building an extra layer of realism in the simulation. So we found that students really got lost and immersed in the simulation experience when they are using the full text capabilities. So that's pretty important. Moving on to the next question, if you don't mind, because we have a couple here. Are we able to pre-populate orders for nursing students to prioritize interventions in a custom case? Most definitely. You have the ability to limit the available orders on a patient-by-patient scenario basis. And you can reuse any of the existing orders from any of the patients that you have access to, including all the bundled patients. Okay, so that's a definite yes. Can you purchase shared cases among subscribers of programs? Yes, you can. Actually, we have more than one ways to share cases. The easiest way, you can share full access to your scenario that you're working on with anybody else using the PCS platform, and they can become co-collaborators in creating the patient. So you can remotely from the other end of the world participate and split it up. Some of you might work on the orders, others on the conversational responses. And finally, once the patient scenario is ready for prime time and you're really proud of what you accomplished, you can decide to make it available to all PCS users, but they cannot make changes to your scenario. They can only use it as is, and they will be seeing your credits. So they will see who it is, who created it, and where it is coming from. Do you have to custom create all of our own patients? Does it come with pre-made patients and scenarios? Yes, Spark comes bundled with 10 scenarios, a wide range of mostly communication-focused scenarios, but as we are adding more and more physical exam elements, we now have a acute chest pain case and more are coming. So as of today, 10 patient scenarios ready for use on day one. Additionally, Spark also comes with the service that, depending on the scale of your setup, we are offering 1, 2, or more custom patient scenarios created for you based on your scenario by our content team. Are they all outpatient? No, we have a bunch of environments where you can place your patients. The clinic was just one example. They can also be in a hospital, or they can be an ambulance, or we even have a home environment for telemedicine applications. Is it a yearly per student license cost? I will let Nick answer that one.
So for the cost structure, it's basically a per user cost with a minimum of 200 users. And we have two different options there. So we have an annual pricing option, which is $49 per student per year. At 200 users, that equates out to $9,800 annually to start with. And then for the lifetime purchase, which is just a one-time purchase price, that is $149 per year. And with a minimum of 200 users, that equates out to $29,800 for 200 users.
And yes, unlimited custom patient scenarios can be created with these. Is there an incorporated EHR-like documentation aspect available? Yes and no. Yes, in the read-only aspect of it. So there is a patient file element that students can explore on their own. In a way, the orders component ties into that. No, in the sense that we don't simulate the medical note-taking process is often used in electronic health record applications, at least not as of today. Having said that, we have fully open APIs and happy to connect with any third-party systems, including EHR and EHR simulators. Are the sims recorded for facilitators to evaluate student performance at a later time? The full transcript and every single student action and simulator reaction are recorded and can be evaluated by facilitators at any later time. There is actually a checkbox element for the facilitator to score and evaluate student performance. And of course, they can also leave log messages visible to the learners, and learners can come back and review their archive recordings at any time later. So yes, all those capabilities are part of the PCS platform. We're getting to the end of the hour, and we really didn't want to go over time. We're happy to answer further questions, but before we answer this next one, I just want to emphasize that we would be thrilled to answer any questions you may have. Just email us at info@pcs.ai or sales@pcs.ai, pretty much anything at pcs.ai, and we will get it and answer your questions as quickly as possible. Are sims recorded for, great, thank you. Are any of the 10 patients? Yes, we actually have a pediatric patient, a 10 to 12-year-old girl, and we're planning on adding a maternal patient soon. So, yep. Most of our new patient developments and avatar developments are driven by our users. So right now we're working with the Veterans Administrations as one of our users, working on a PTSD situation veteran, and that's how new avatars are added to the system. So just because we don't have it today, we would be thrilled to work with any of you to add additional avatars, scenarios, and environments.
And actually, Balazs, one thing I just want to add on top of that is any new users that we bring on, we actually have a full content team, and we assist and actually help develop your first custom patient case. So you guys are really able to hit the ground running in cases that already fit into your curriculum.
And in terms of how difficult it is to train the AI, I would say that if you have enough information that you could train a human standardized patient, that you can also, you also have the information to train a PCS Spark patient. The tools are somewhat different, but basically the mindset and the methodology is actually really similar. That's why our content team is happy to help you with that.
All right, should we wrap it up?
I think so. So thank you very much all for joining us today. This was really interesting as we tried to do two very different things in in a single hour. I hope you learned something interesting, or at least you found that AI is complicated in the first half of the presentation. And I hope that the capabilities and the possibilities that are available today with the PCS Spark platform were intriguing to you as presented by Nick in the second half of the session. So thank you very much. And
thanks, everyone.